This video is going to go through the valence electrons. We're going to recap that, and that's important. You might be like, oh man, I swear we just talked about this in the last video. We did, and we're going to talk about it in this video, and we're going to talk about it in the whole next unit. The whole next unit is going to be all about valence electrons. We're going to talk about dot structures as well. So we got to make sure we understand this stuff. And I'm going to go through like some sample questions that we're going to have. All right, so this should just be a review. This is nothing new. It should not be anything new. Each column, on the periodic table. All right, once again, these are these vertical rows. Sweet heavens. These vertical columns. Those are called groups. All right, and they're also called families because they oftentimes share common characteristics. All right, and the horizontal rows, all right, these bad boys here, these are called periods. All right, these are called periods. Those horizontal rows are called period. If it helps you to remember, you write out something when you're writing out a sentence, you write it out like this, you put a period at the end. All right, so horizontally you write out sentences, so a horizontal row is a period. You could think of something like, hey, I stand up for my family. All right, you should stand up for your family. These are vertical columns. Families are vertical columns. Just so you don't get those mixed up in the verbiage of them. All right, that might be stupid. You might be like, that's dumb. No, don't use it. All right, who's asking you? But those are just good ways to remember it. That could be helpful ways to remember it. All right, and so each period on the periodic table is the energy level. All right, we'll tell you how many energy levels that atom has. So these all have hydrogen and helium. All right, these are both the only two in period one. Once again, period is a horizontal row. So when I say period, it's the horizontal row. They only have one energy level. All right. All elements in group 2 have 2 energy levels. All elements in group 3, oh my gosh, I'm saying group. I'm looking at the word group. I'm going to cross that out. All elements in period 2 have 2 energy levels. All elements in period 3 have 3 energy levels. In period 4 have 4 energy levels. Right? And that shouldn't be anything too shocking. The element in the group, now the vertical column, that will be how many valence electrons there are. And this is really important because that's all we're going to talk about in the next unit. When we make bonds, how many valence electrons they have. We talked about this in the last video. All elements in group 1, they all have 1 valence electron. All elements in group 2, they all have 2 valence electrons. We skip this dip. We say, whoop, we're just going to jump right over that dip, skip the dip, the transition elements. They have varying oxidation states. We're not going to worry about that. The next group has 3, 4, 5, 6, 7, 8, except helium, because I'm stupid. All right, that one only has 2, because it can only have 2 electrons, but it's still considered a full outer shell. All right, so this is how you determine the valence electrons. All right, we talked about that in the last video. I wanted to talk about it again because it's important, and that's really what Lewis dot structures are. So some of the type of test questions I'm going to give you, I wanted to make sure I showed them to you here. So if you see like an image that looks like this on the test, I might say, hey, what element is this? You'd be like, how am I supposed to know that? He said protons identify the element. Is that one proton? I don't you know how you guys freak out about stuff. So what we have to do there is we have to look. So if it has 3 energy levels, we're going to assume these are filled with electrons because you can't go to the next energy level without having this. You can't go to the next energy level without first filling that first level. All right, so this one has 3 energy levels. All right, so if it has 3 energy levels, 1, 2, 3, all right, just like we talked about here, these it'll be in that period, all right, because it has 3 energy levels. So I just got to count the energy levels it has. I know it's in period number 3. All right, what group number is it in? Well, it's got 1 valence electron, so it's in group 1. Well, that's pretty simple. All right, so now all I got to do is find the element that is in group 1. Period 3, there it is. All right, and that element is sodium, Na. All right, so that is sodium. So if I give you a question on the test, and I say, what element is this? And you're like, I don't know. There's no protons, because I told you protons identify the element. You have to use the other clues to help you. All right, so 2 valence electrons. 2 valence electrons with 3 energy levels would be magnesium. This has 3 energy levels. Be in period 3. It has 2 valence electrons. It'd be in group 2. It would be magnesium. All right. And once again, valence electrons, they are electrons in the highest occupied energy level of the atom. All right, that's what we talk about when we talk about bonding. All right, so when we talk about bonding in the next unit, that's why this is so important. All right, and so depending when you're watching this video, we've done the electron energy level lab. Some have, some haven't. Where we went through and we kind of mapped this out. We went through and we mapped out the atom. Well, I'm going to show you a shortcut now instead of just being able to figure out what the, to have to draw an atom to figure out how many electrons it has or what the configuration is. We're going to draw it in a much simpler way. All right, so we said that the first energy level can hold 2. We talked about this in the last notes also. That's filled with 2. You can't put more than 2 in that first energy level. The second can hold up to 8 electrons. The third can hold 8. It technically can hold 18, but then you get into orbitals. I don't want to get into orbitals. We're going to let Mr. Coring deal with that. So for our purposes, we're going to say the third can hold up to 8. All right, and we're not going to go much past 4 anyway. So, but if you ever did the math and you were trying to figure out, like, wait a minute, there's a lot more electrons left over. Why wouldn't there be? Because like some levels can, some can hold up to 32. And they can really become full quickly. All right, so we're going to try to keep it very basic, just for the first 20 elements or so. But as you get further down, more electron levels can hold more. All right, but basically when you draw a dot structure, all you're doing, instead of having to redraw the entire element, all you do is you write the atomic symbol. All right, and then you write down just the valence electrons that it has. All right, so it's pretty simple. So if I look at, let's say, all the elements in group 1, so hydrogen, lithium, sodium, potassium. I'm not going to go through all of them, but you get the idea. Rubidium. I could keep going. All right, as I go down this periodic table, they all have just 1 electron in their outer shell. All right, so it's pretty simple. All I do, because we know that the outer level electrons is based on the group that it's in. So to write a valence dot diagram, a valence dot structure, all you do, an electron dot diagram, you just put 1 dot next to all of them. They all have the exact same valence electrons, so they're going to all have the same dot structure as well. The only difference is that it's obviously the symbol, the chemical symbol changes. All right. Well, what if we skipped over here once again? So we know that these are stupid helium. We know that these are. When we skip the dip, let's say I go to group 14, 4A, whatever you want to call it, carbon. Let's say I go to carbon. Well, we just looked at that, so it shouldn't be that tricky. Now, typically what most people do is they'll tell you to draw a line. You got to put, before you pair the electrons, you got to draw 1 on each side. All right. So then carbon, since it's in group 14 or group 4A, whatever you want to call it, it has 4. When you skip the dip, we're just counting the groups. It has 4, so carbon would look like that. All right. Nitrogen is right next to it. You don't have to do this. This is just something. But you want to go through. You actually should go counterclockwise. So it goes here, 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 here. And then you put the other one on the opposite side. So you're going to go through, if I kept going, if I went all the way to, let's say, argon, which is right here. Argon. Argon has 8. So you just go through and you would just continue to pair it with all those. All right, so that's all you're doing for that. All right, you're just doing however many electrons it has in its outer shell. That's all you're doing. So I'm going to have you guys practice that. So once again, hydrogen would look like this. Phosphorus is here. Once again, just count what column it's in. Oh, it's in the 5th column. So it'd be 1, 2, 3, 4. And then we'll come back around and pair it 5. All right, that's all you do for valence or for Lewis dot structures. Now, I will ask you questions like on the test where I might just give you like a random element, like element X has this. What group is it in? So I might reverse the problem on you. Well, you're like, well, it's got 2, so it's going to be in group 2. So instead of asking you to say, hey, what element, or what would this dot structure be, what I'm likely going to do is reverse that process and say, hey, if element W, whatever, if it was in group, if it had this dot diagram, what group would it be in? It would be in group 17. All right.